Lesson 3 introduces to us deductive reasoning, and it also talks about applying the laws of detachment and the law of syllogism in logical reasoning. So the definition for deductive reasoning, it says it is the process of using logic to draw conclusions from given facts, definitions, and properties. And they're going to ask us to think about whether we are making decisions or conjectures or conclusions based on inductive reasoning skills or deductive reasoning. And when you're trying to decide that, it says to ask yourself if the conjecture is based on patterns or definitions and facts. Because we said in lesson 1 that if we have something based on patterns or specific cases that are true, we're using inductive reasoning. And definitions, facts, properties, we would be using deductive reasoning. So we're going to take a look at example A, number 1, where it says, there is a myth that you can balance an egg on its end only in the spring equinox. A person was able to balance an egg on July 8th, September 21st, and December 19th, and therefore the myth is false. We want to know if our conclusion is the result of inductive reasoning or deductive reasoning. When they decided the myth was false, are they using a pattern of events or definitions and facts? It can be kind of confusing when you're going through these, but after you go through a few examples, they get a little bit easier. In this case, because the person balanced the egg 3 different times and it worked, they decided the myth was false. That is actually using inductive reasoning. They were testing it out, and they saw that the pattern, it balanced on the 8th, it balanced on the 21st, and it balanced on the 19th. And so, using those specific cases, they decided inductive. In number 2, it says there is a myth that the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in a photograph taken from 180 miles above the Earth. The moon is about 237,000 miles from Earth, and therefore the myth cannot be true. Are we using inductive reasoning or deductive reasoning? In this case, the fact that the Great Wall is barely visible from a photograph taken from 180 miles above the Earth is going to say that it is deductive reasoning to decide that the myth cannot be true. It's factual that you can't see the Great Wall in that photograph. It's not going to be visible from the moon. Question number 3. If John is late making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month, so he concludes that he will be assessed a late fee of $50. Inductive reasoning or deductive reasoning? Well, the wording is important, and the fact that he'll be assessed a $50 late fee is going to say John is using deductive reasoning. This was probably in his terms of agreement that it was stated it's a fact he'll be charged that late fee. Now, if the wording had said something like John was late making his payment in June and had to pay a $50 late fee, and he was late making his payment in August and had to pay a $50 late fee, and now John is late making his payment in October, he concludes he'll pay the $50 late fee. That, I would say, is using inductive reasoning because it's a pattern that's happened to him over and over, and that's why he's concluding. But in this case, he knew the terms of agreement. In number 4, it says every time Katie has worn her favorite socks to a softball game, she has gotten at least 1 hit. Katie is wearing her favorite socks to the game tonight, so she concludes that she will get at least 1 hit. Every time she wears those socks, that's It's a pattern happening over and over, and so that is going to be inductive reasoning. At the top of page 2, it says, an auto mechanic knows that if a car has a dead battery, the car will not start. A mechanic begins work on a car and finds the battery is dead. What conclusion can she make? We can conclude, right, that the car will not start. Now, if the wording was a little different and we looked at it like this, saying that suppose the mechanic begins work on a car and finds that the car will not start, can the mechanic conclude the car has a dead battery? Well, in this case, my car won't start, but would you agree there could be other reasons than just a dead battery that it won't start? Could be an alternator that's bad, or other things. So in this case, we really can't draw a conclusion. Nothing for sure, anyway. It says, congratulations, you've just used one of the laws of deductive reasoning. In deductive reasoning, if the given facts are true and you apply the correct logic, then the conclusion must be true. So the law of detachment says this: if P then Q is true, and P is true, then Q is true. Sometimes that can be confusing, but we're going to look at some specific word examples, and I think that helps clear it up. We're going to try and decide if our conclusions are valid or invalid, true or false. And when we have these statements, we are a lot of times given statements that are labeled as givens. I want you to know that the givens are always going to be true. Those are for sure. So in number 1, we are looking to, or we are given the statement, if a student turns in a permission slip, then the student can go on the field trip. Felipe turned in his permission slip. Can we conclude that Felipe can go on the field trip? Yes, that is a valid conclusion. Here, turning in the permission slip P, then Q can go on the field trip. Well, it says Felipe turned in his permission slip. P is true. Q, the second part, must be true. Number 2. If Mika goes to the beach, she will wear sunscreen. Mika is wearing sunscreen. Can we conclude that Mika is at the beach? In this example, we are actually going to say that's an invalid conclusion. A counter example might be that Mika is wearing sunscreen. She could be at the amusement park. She could be at the baseball diamond. Here, my if P then Q, well, wearing sunscreen is Q. Doesn't necessarily mean that P is true. Number 3, if 2 angles form a linear pair, then their non-common sides are opposite rays. Angle AED and AEB form a linear pair. Now, if I were going to give you a picture for this, it would look something like this. AED, AAB. Can we conclude that ED and EB are opposite rays? Well, because these form my linear pair, yes, that is a valid conclusion. They must be opposite rays. The second law that we're going to introduce is called the law of syllogism. The law of syllogism allows you to state a conclusion from 2 conditional statements when the conclusion of one is the hypothesis of another. Symbolically, the law of syllogism says that if P then Q and Q then R are true, then P then R is also true. I kind of like to put that together. It reminds me a little bit of the transitive property. If P then Q is true and Q then R is true, in my mind these kind of cancel. P then R has to be true. It's kind of the way I see it symbolically. So in example C, again, we're going to decide if we have a valid or invalid conjecture. My given statement, it says that if a figure is a kite, then it is quadrilateral. If a figure is a quadrilateral, then it is a polygon. Can we conclude that if a figure is a kite, it is a polygon? Well, if we break this up, if P then Q, and this says Q then R, we know P then R is true. Does this match? P then R? Yes, we can conclude if the figure is a kite, then it is a polygon. Example 2, my given statement says that if a number is divisible by 2, it is even. If it is even, then it is an integer. Can I conclude that if a number is an integer, it is divisible by 2? There are a couple ways you could do this. You can look at the if P then Q and Q then R statement. You can also think about if you can find a counterexample. If I can find a counterexample, it's not true. But this, if a number is an integer, it is divisible by 2, is going to be invalid. Symbolically, this really says if R then P, and that's not necessarily the case. But I also know my integer divisible by 2, well, 11 is an integer, and that's not necessarily nicely divisible by 2. Sometimes they are also going to ask you to draw a conclusion, and there are cases when it's not possible to draw a conclusion, just like when we said the mechanic was working on the car and the car wouldn't start. We couldn't draw for sure conclusion that it was the car battery. Other times you can draw a conclusion. And if you take a look at number 1, it says that if you leave the car lights on overnight, your car battery will drain. If your battery is drained, your car might not start. Alex left his car lights on last night. What conclusion can we confirm? Well, if Alex left his car lights on last night, we can conclude his car might not start. Okay? I wouldn't conclude his battery is drained because that's a given statement. I know that for sure. But my conclusion is that his car might not start. Number 2, if a polygon is a triangle, then it has 3 sides. If a polygon has 3 sides, it's not a quadrilateral. Polygon P is a triangle. What can we conclude? Well, we can conclude if polygon P is a triangle, it is not a quadrilateral. And again, sometimes we aren't able to draw a valid conclusion. Maybe saying, if you go to the beach, then you need to wear sunscreen. If you go to the basketball court, you need to wear tennis shoes. I don't really have a conclusion to draw from there. So sometimes we would opt to say no conclusion possible. Okay, if you have more questions on this, you can come in and see me, or you can check out the online videos that are via our textbook.